Hello, today I will be presenting corrosion from Module 12. What is corrosion? Well, corrosion is most commonly the result of electrochemical reactions. The most common terms to remember when talking about electrochemical reactions is anodes and cathodes. The anode was when the electrode where galvanic reactions generate electrons. It is when the negative ions are discharged and the positive ions are formed. This is where corrosion occurs. The cathode is when the electrode receives electrons. This means positive ions are discharged and negative ions are formed. It's the opposite of the anode, so it also protects against corrosion. It is also beneficial to include what the electrolyte does. So the electrolyte is where the conductor through which current is carried. It includes a aqueous solution or other liquids. Electrochemical corrosion occurs when two metals with different electropositivities come into contact with an electrolyte. This will cause a redox reaction. So what would happen when these two different electropositive metals come into contact? Well, one of them will corrode. But what metal is most likely to corrode? Pause the video and think about it. If you guessed potassium, you would be correct. The reasoning is when two different electropositive metals come into contact with an electrolyte, the more electropositive metal will become corroded, and the less electropositive one is protected against corrosion, as you can see from the diagram provided. Electrochemical corrosion involves oxidation and reduction reactions. Oxidation happens on the surface of metals at the anodic site, allowing the entire surface to corrode, and generates the reduction reaction at the cathode. Oxidation and reduction happen simultaneously with each other. We'll go more in depth and explain what favors corrosion. In electrochemical terms, you can accelerate corrosion of one metal by putting it with a less electropositive metal. Take, for example, this iron nail. If you put it with copper, the corrosion of the iron will speed up due to the copper being less electropositive. There are also things we see in our day-to-day lives that favor corrosion. So, for example, especially salt water is an electrolyte which conducts ions. This will lower the electrical resistance of water, which in return allows salt to speed up the rusting process. Cars in the winter are more acceptable to this because of the use of road salt to melt snow. Vinegar contains acetic acid. This means the positive hydrogen ions in the acid remove the electrons from the metal, which leads to it being more ionized. The acetic acid in vinegar can also serve as an electrolyte in the reaction, causing the metals to corrode faster. Water always contains dissolved oxygen, which is corrosive to metals. Metals also deteriorate rapidly in human conditions, which rain offers excellent medium for rest. This allows ions to pass freely between iron and oxygen in water. An electrochemical reaction draws oxygen from the air where water, iron, and air interact, creating hydroxide ions in the water, which allows metals to rust faster. This also relates to the example from earlier, with iron and copper in the water, allowing for rapid corrosion. Bleach is another thing that we see to our day-to-day lives that favor corrosion. It contains a chemical called sodium hypoxide that acts as the oxidizing agent in the reaction, that is, ionizing other materials by removing electrons from them, hence accelerating corrosion. Iron, for example, loses electrons more rapidly in bleach than water. What can help protect against corrosion? So just like how copper accelerates corrosion in iron, magnesium does the opposite. As seen in the diagram, there's an iron nail and magnesium ribbon wrapped around it. So magnesium can protect against rusting because it has a higher electropositivity than iron. This goes for any other metal that is more electropositive than iron. The one that is more electropositive is the oxidation, and the iron would be the reduction because magnesium would be giving it electrons. So with applying this knowledge, I presented an example that we can walk through. So as we know by now, zinc can protect iron from corrosion because it has a higher electropositivity. So we can now use zinc as a coating for the iron. In this case, zinc is acting as a negative terminal that is releasing electrons. This would be considered oxidation. The electrons will release flow to the iron, which will cause the zinc outside to corrode. With this happening, it allows the electrons to escape to the iron and will be gained from the oxygen and water to form hydroxide ions in the cathode where the reduction will take place. An interesting study recently came out from the Journal of Electroanalytical Chemistry. It stated that corrosion inhibitors is one of the most effective methods for metal protection against corrosion. So a corrosion inhibitor is a chemical compound that when added to a liquid or gas can decrease the corrosion rate of a metal that comes into contact with the fluid. So they discovered that they could actually derive this aromatic compound from plants that can act as a corrosion inhibitor because of its similar properties, which is really cool because plants being able to protect metals due to their chemical makeup.